Here I'm going to be talking about this idea of the enhanced greenhouse effect, which is here, and the greenhouse effect, and also this idea of albedo. Now, just to look at our definitions, we have our greenhouse effect is shortwave radiation received from the sun causes the Earth's surface to warm up. Earth then emits longer wavelength radiation, infrared, which is absorbed by some gases, e.g. methane, water vapor, carbon dioxide, nitrous oxide. Those are our so-called greenhouse gases in the atmosphere, and re-radiate in all directions. This extra warming of the Earth's atmosphere is known as the greenhouse effect. Now, you need to just know that definition off by heart. Now, the idea of enhanced is that human activities, mainly relating to the burning of fossil fuel, those are things that are caused over millions of years, such as coal, oil, natural gas, and so forth, have released extra carbon dioxide into the atmosphere, thereby enhancing or amplifying the greenhouse effect and a possible cause of global warming. So, just to explain this now in relationship to the Earth, we have energy coming in from the sun, comes in, and it comes in as short wavelength. So this is our ultraviolet wavelength light. This is our visible light, and it comes in, and your greenhouse gases, your carbon dioxide, your water vapor, your methane, and so forth, don't absorb the short wavelength, but it comes in here and it hits the Earth, and it's absorbed by the Earth's surface. So you get a warming, and then the Earth will re-emit that out in the form of a longer wavelength. So it comes out in a longer wavelength, and that's your infrared. It's a longer wavelength. It's actually a lower energy wave, and this infrared is absorbed by your greenhouse gases. And the reason why the infrared is absorbed is that the natural frequency of your H2O, of your CO2, and of your methane gas, nitrogen and nitrous oxide also, the natural frequency of these all correspond to this infrared, and so you get resonance occurring. It causes those molecules to vibrate, and in so doing they receive that energy, and then they re-radiate that energy, and that is absorbed, that re-radiated energy is absorbed by the atmosphere. It's in all directions. This is all directions. So it's absorbed by the surface of the Earth, it's absorbed by the atmosphere, the lower atmosphere, and it tends to warm up the Earth. Now, the Earth system that we have is, if I just go back here, the Earth system reflects also a certain amount of energy, and this is this idea of albedo. It's a fraction of the total incoming solar radiation received by a planet that is reflected back from into space, or rather the total solar radiation scattered by a planet to the total solar radiation received by a planet. We have it in, if I go to my data booklet, we have it in this formula over here. It's given in this formula here, and this is the total scattered power over the total incident power. Now, the albedo varies according to the materials. So things that are black, like roads and so forth, these will have a low albedo. So this is actually a fraction, 0, close to 0. This is a low albedo. This is where most of the energy is absorbed. And it goes through to 1, where you get all the energy, all the power is being reflected. This is close to 1. You would have things like snow cover, where you'd get about 0.8, 0.9. Green grass and so forth may have an albedo of about 0.15 and so forth. And so when energy from the sun hits the Earth, it can cause it of it to be reflected and some not. So we have this situation over here. We've got our energy coming in. This is our atmosphere. Some is absorbed, some is reflected. So you get a certain albedo that's taking place there all the way. So even though we may have a solar intensity hitting the atmosphere of around about 1,400 watts per square meter, when it's in direct sunlight, a certain amount of this will be reflected. Also, a certain amount will be reflected by the surface of the Earth. And by changing the conditions, by changing the surfaces of the Earth, for instance, if we have global warming and all the ice caps melt and so forth, this is going to lower the albedo and therefore possibly cause an increase in the amount of energy that has been absorbed by the Earth.